CI/CD Scalability with Spring Boot Introduction. CI/CD Scalability means designing build, test, deployment, and release pipelines that can handle growing Spring Boot applications, more developers, more microservices, and more production releases without becoming slow or unreliable. Spring Boot developers often learn CI/CD scalability to improve build speed, test automation, deployment reliability, Docker image creation, Kubernetes deployment, rollback strategy, release confidence, production scalability, microservice delivery, cloud-native operations. A common learning topic is, how can Spring Boot developers design scalable CI/CD pipelines? This guide explains CAP, CI/CD basics, Spring Boot build pipeline, GitHub Actions pipeline, Gradle Maven optimization, test strategy, Docker image builds, Kubernetes deployment, rolling updates, blue-green deployment, canary deployment, environment promotion, security scanning, monitoring, rollback, best practices, questions. This is one of the best practical guides for backend developers learning CI/CD scalability with Spring Boot. Simple definition. CI/CD is an automated process that builds, tests, packages, and deploys applications. CI means continuous integration. CD means continuous delivery or continuous deployment. Simple flow. Developer pushes code. CI pipeline starts. Build application. Run tests. Create Docker image. Deploy to environment. Monitor release. Why CI/CD scalability matters. Small project. One Spring Boot app. One developer. Few tests. Manual deployment. Growing project. 20 microservices. 10 developers. Thousands of tests. Multiple environments. Kubernetes deployment. Daily releases. Without scalable CI/CD, builds become slow. Tests become flaky. Deployments fail often. Releases become risky. Rollback is difficult. Developers wait too long. Production bugs increase. With scalable CI/CD, faster feedback, safer releases, repeatable deployments, better testing, easier rollback, better team productivity. CI/CD architecture for Spring Boot. Typical architecture. Git repository dash, CI/CD pipeline dash, build Spring Boot app dash, run tests, build Docker image, push image to registry, deploy to Kubernetes, run health checks, monitor logs, and metrics. Cloud-native Spring Boot architecture. GitHub, GitLab, Bitbucket, CI/CD tool, Maven, Gradle, Docker, Buildpacks, container registry, Kubernetes, Prometheus plus Grafana. Spring Boot applications can be containerized using Docker files or cloud-native build packs to create optimized container images. CI versus CD term meaning. CI build and test every code change. CD automatically prepare or deploy releases. Continuous delivery. Deployment is ready. Manual approval may exist. Continuous deployment. Deployment happens automatically after checks. Simple idea. CI checks code quality. CD releases code safely. Step 1. Understand basic Spring Boot pipeline. Basic pipeline. Check out code. Set up Java. Build project. Run unit tests. Run integration tests. Package jar. Build Docker image. Push image. Deploy. For Maven. .menw clean verify. For Gradle. Gradle clean build. Step 2. Use Maven wrapper or Gradle wrapper. Use wrapper scripts. Maven. .mvnw clean verify. Gradle. .f Gradle clean build. Why? Same build tool version. Reliable local builds. Reliable CI builds. No global setup required. Fewer environment issues. Best practice. Always commit Maven wrapper or Gradle wrapper files. Step 3. GitHub Actions example for Spring Boot. Example pipeline. Name, Spring Boot CI. On, pull request, push, branches, main, jobs, Build runs on Ubuntu latest. Steps: name, checkout code uses. Actions checkout at v4. Name, setup Java uses. Actions setup Java at v4 with distribution, Tamarin, Java version 21, cache, Maven. Name, build and test run, Maven clean verify. GitHub Actions supports dependency caching to reuse dependencies and build outputs, which can improve workflow speed when configured correctly. Step 4. Gradle GitHub Actions example name, Spring Boot Gradle CI. On, pull request, push, branches. Jobs, build, runs on, Ubuntu latest. Steps: uses Actions checkout at v4. Uses Actions setup Java at v4 with distribution, Tamarin, Java version 21, cache, Gradle. Name, build run. Gradle clean build. Use this for Spring Boot Gradle apps, Kotlin backend apps, multi-module builds, cloud-native services. Step 5. Pipeline stages. Scalable CI/CD should separate stages clearly. Validate, build, test, package, security scan, image build, deploy to dev, deploy to QA, deploy to staging, deploy to production. Each stage should answer one question. Stage question. Validate. Is code format and config valid? Build. Does the app compile? Test. Does functionality work? Package. Can we create deployable artifact? Scan. Is it safe enough to deploy? Deploy. Can it run in environment? Monitor. Is the release healthy? Step 6. Build scalability. Build scalability means builds stay fast even as codebase grows. Techniques. Check. Dependency caching, build cache, parallel jobs, split unit and integration tests, avoid unnecessary rebuilds, use multi-module builds carefully, use incremental builds locally, avoid slow startup tests in every stage. Example. Run unit tests on every PR. Run full integration tests before merge or nightly. Step 7. Test strategy. Testing pyramid. Many unit tests, some integration tests, few end-to-end tests. For Spring Boot, test type purpose. Unit test, test service logic quickly. Slice test, test controller repository layer. Integration test, test app with database container. Contract test, test API compatibility. E2E test, test full user flow. Good scalable strategy. Fast tests run on every pull request. Slow tests run before release or in parallel. Step 8. Unit test stage. Example. .mvu test or .gradle test. Unit tests should be cast, isolated, cast, repeatable, not dependent on external services, cast, easy to debug. Example unit test target. Order service, payment validator, user mapper, JWT service. Step 9. Integration test stage. Integration tests verify real components. Example tools. Testcontainers. Test container. RabbitMQ container. Kafka container. Redis container. Wiremock. Example. Spring Boot app. Testcontainers PostgreSQL. Use integration tests for database queries, transaction behavior, messaging, API contracts, application startup. Step 10. End-to-end test stage. E2E tests validate user flows. Example. React UI, Spring Boot API, database, message broker. Tools. Sure, Playwright, Cypress, Selenium. Example flows. Check. Login. Check. Create order. Check. Profile update. Check. Admin dashboard. Best practice. Keep E2E tests small and focused. Do not depend on too many shared records. Step 11. Package Spring Boot jar. Maven. .mvw clean package. Gradle. .gradle boot jar. Output. Target app. .jar. Or build lids app jar. Spring Boot executable jar. Java jar app.jar. Step 12. Build Docker image. Docker file example. From Eclipse Tamarin 21 JRE. Work dir app. Copy. Target app.jar. App.jar. Expose 8080. Entry point. Java -jar app.jar. Build. Docker build T order service 1.0.0. Better production Docker file. From Eclipse Tamarin 21-JRE. Run add group-system app and add user-system-ingroup app. Work dr app. Copy target app.jar app.jar. User app. Expose 8080. Entry point java-jar. App.jar. Best practices. Check. Run as non-root. Keep image small. Avoid copying secrets. Use fixed image tags. Scan image vulnerabilities. Step 13. Build image with Spring Boot Buildpacks. Maven. .mvnw Spring Boot build image. Gradle boot build image. Buildpacks can create Docker-compatible container images without writing a Docker file. Spring Boot supports both Docker files and cloud-native buildpacks for container images. Use buildpacks when you want standardized images. You prefer less Docker file maintenance. You want optimized Java container layering. Your team uses platform build pipelines. Step 14. Push image to registry. Example image. GHCR.io company order service 1.0.0. Docker commands. Docker tag order service 1.0.0 ghcr.io/company order service.1.0.0 Docker push ghcr.io/company order service.1.0.0 Common registries. GitHub Container Registry, Docker Hub, AWS ECR, Azure Container Registry, Google Artifact Registry. Best practice. Tag images with commit SHA and release version. Avoid using only latest. Step 15. GitHub Actions Docker build. Name, build Docker image. On, push, branches, main, jobs, Docker, runs on Ubuntu latest. Steps. Uses, Actions checkout at v4. Uses, Actions setup Java at v4 with distribution, Tamarin, Java version 21, cache, Maven. Name, build jar run, /mvnw clean package -d skip tests. Name, build Docker image, run, Docker build T order service, github.sha, name, login to registry run, echo $secrets.registry token plus Docker login ghcr.io, u$github.actor, name, push Docker image run, Docker tag order service $c GitHub SHA, ghcr.io company order service $c GitHub SHA, Docker push ghcr.io company order service $c GitHub SHA. Step 16. Kubernetes deployment. Kubernetes deployment example. API version, apps, v1, kind deployment, metadata, name, order service, spec, replicas, app, order service, template, metadata, labels, app, order service, spec, containers, name, order service, image, ghcr, io, company, order service, commit SHA, ports, container port, 8080, service, API version, v1, kind service, metadata, name, order service, spec, selector, app, order service, ports, -port, 8080, target port, 8080. Kubernetes is designed for automating deployment, scaling, and management of containerized applications. Step 17. Kubernetes rolling update. Rolling update gradually replaces old pods with new pods. Kubernetes rolling updates allow deployment updates with zero downtime by incrementally replacing old pods with new ones. Flow. Old version pods running. New version pod starts. New pod becomes ready. Old pod removed. Command. kubectl, rollout status, deployment, order service. Rollback. kubectl rollout undo deployment. Order service. Step 18. Readiness and liveness probes. Readiness probe. Can this pod receive traffic? Liveness probe. Is this pod alive? Spring Boot Actuator supports Kubernetes-style readiness and liveness states, and Kubernetes should not route traffic to an instance when readiness is unready. Example: readiness probe, HTTP GET, path, actuator health, readiness, port 8080, initial delay seconds, 20, period seconds, 10. Liveness probe, HTTP GET, path, actuator health, liveness, port 8080, initial delay seconds, 60, period seconds, 20. Kubernetes also documents liveness, readiness, and startup probes for containers. Step 19. Spring Boot Actuator Configuration. Add dependency. Dependency. Group ID, org.springframework.boot. Group ID. Artifact ID, Spring Boot Starter Actuator. Artifact ID. Configuration. Management. Endpoints web. Exposure include health info, Prometheus endpoint, health, probes, enabled, true. Useful endpoints. Actuator health readiness, actuator health liveness, actuator Prometheus. Step 20. Environment promotion. Scalable CI/CD usually promotes the same artifact across environments. Flow. Build once, deploy to dev, promote to QA, promote to staging, promote to production. Important rule. Do not rebuild artifacts separately for each environment. Build once, deploy many times. Why? Same artifact tested everywhere. Fewer production surprises. Easier rollback, better traceability. Step 21. Environment configuration. Use environment-specific config. Dev, QA, staging, prod. Spring profiles. Spring profiles, active, prod. Kubernetes config map. API version. v1 kind config map. Metadata. Name, order service config, data, Spring profiles active, prod. Server port, 8080. Use secrets for sensitive values. DB password. JWT secret. API key. Never hardcode secrets in. Docker file. GitHub Actions YAML. Config map. Application prod. Docker YML. Committed to Git. Step 22. Deployment strategies. Strategy meaning rolling update. Replace pods gradually. Blue-green switch traffic from old environment to new. Canary, send small traffic to new version. Feature flags, enable disable features dynamically. Manual approval, human approval before production. Use rolling update for normal releases. Canary for risky releases. Blue-green for quick rollback needs. Feature flags for business features. Step 23, blue-green deployment. Blue-green means blue equals current production, green equals new version. Flow. Deploy green. Test green. Switch traffic from blue to green. Keep blue for rollback. Benefits. Rollback, fast rollback, low downtime, safer production release. Challenges. Needs extra resources. Database compatibility matters. Traffic switch must be controlled. Step 24. Canary deployment. Canary means release new version to a small percentage first. Flow. 95% traffic means old version. 5% traffic means new version. Monitor errors and latency. Increase to 25%. Increase to 50%. Increase to 100%. Use Canary when yes, release is risky. User impact must be limited. Yes, monitoring is strong. Yes, rollback must be quick. Step 25. Feature flags. Feature flags allow releasing code without enabling it immediately. Example: code deployed to production. Feature disabled. Enable for internal users. Enable for 5%. Enable for all users. Safer releases. Faster rollback of feature. Testing in production-like environment. Less deployment pressure. Important. Remove old feature flags after they are no longer needed. Step 26. Security scanning in CI/CD. Add security checks. Class, dependency vulnerability scan, container image scan, secret scan, static code analysis, license compliance, infrastructure as code scan. Example tools. Check. OWASP dependency check. Sneak. Triv. GitHub Dependabot. SonarCube. Checkov. SemGrep. Pipeline stage. Build, test, security scan, image scan, deploy. Best practice. Fail pipeline for critical vulnerabilities. Warn for lower severity based on policy. Step 27. Quality gates. Quality gates decide whether code can move forward. Examples. Code build must pass. Unit tests must pass. Integration tests must pass. Code coverage threshold. No critical vulnerabilities. Docker image scan passes. Kubernetes manifest validation passes. Manual approval for production. Example. If quality gate fails, deployment stops. Step 28. Database migration in CI/CD. Spring Boot apps often use Flyway, Liquibase. Migration flow. App release includes migration scripts. Migration runs before or during deployment. ACK starts with expected schema. Best practices. Key. Backward compatible migrations. Key. Avoid destructive changes first. Key. Add column before using it. Key. Deploy code that supports old and new schema. Key. Remove old columns later. Key. Test migrations in staging. Dangerous. Drop column and deploy new app at same time. Better. Expand means migrate, means switch, means contract. Step 29. Rollback strategy. Rollback should be planned before production deployment. Rollback options. Curb. Kubernetes rollout undo. Curb. Redeploy previous image tag. Curb. Switch traffic back in blue-green. Curb. Reduce canary traffic to 0. Curb. Disable feature flag. Restore database backup if needed. Important. App rollback is easy. Database rollback is hard. Therefore, check. Design backward compatible DB changes. Keep previous image tag. Store deployment history. Test rollback steps. Step 30. Monitoring after deployment. After deployment, monitor. Check error rate. Check latency. Request count. CPU usage. Memory usage. Pod restarts. Database errors. Queue depth. Consumer lag. Health check failures. Business metrics. Tools. Spring Boot Actuator. Spring Boot Micrometer. Prometheus. Grafana. OpenTelemetry. ELK Loki. Datadog New Relic. Deployment is not complete when pipeline says success. Deployment is complete when application is healthy in production. CI/CD Scalability Architecture Developer. Pull request. Fast CI checks. Merge to main. Build artifact. Build Docker image. Push registry. Deploy dev. Run smoke tests. Promote staging. Run integration E2E tests. Manual approval. Deploy production. Monitor. Rollback if needed. Pull request pipeline. Run fast checks. Compile. Unit tests. Formatting. Static analysis. Basic security scan. Small integration tests. Goal. Give developer feedback quickly. Avoid. Running every slow E2E test on every small PR. Main branch pipeline. Run deeper checks. Full build. Full test suite. Integration tests. Docker image build. Image scan. Deploy to dev. Smoke tests. Goal. Main branch should always be deployable. Release pipeline. Run production-focused checks. C. Staging deployment. C. E2E tests. C. Performance smoke test. C. Migration check. C. Manual approval. C. Production deployment. C. Post-deploy monitoring. Goal. Release safely with rollback path. Scalable pipeline design for microservices. For many services, user service, order service, payment service, inventory service, notification service. Avoid. Every change rebuilds and redeploys every service. Better. Detect changed service. Build only affected service. Run relevant tests. Deploy only affected service. Strategies. Path filters, monorepo build tools, service-specific pipelines, shared reusable workflows, dependency graph, contract testing. Monorepo CI/CD. Monorepo. Repo/user service/order service/payment service/common lib/deployment. Scalability challenge. One small change should not rebuild everything. Use. SEX, path-based triggers. SEX, changed file detection. SEX, module-level builds. SEX, parallel workflow templates. Example, change in order service. Build order service only. Run order service tests. Deploy order service multi-module Spring Boot CI/CD. Gradle example. Platform, common, user service, order service, and payment service. Build one module. Gradle, order service build. Build with dependencies. G, Gradle-order service build-continue. Maven module build. MVNW-PL order service-AM clean verify. Performance testing and CI/CD. Do not run heavy load tests on every PR. Use levels. Stage performance test. PR basic performance smoke. Staging, medium load test. Pre-production, full load test. Production, real user monitoring. Tools. K66, JMeter, Gatling, Locust. Example, smoke test. Check API orders, responds under 500 milliseconds for small load. Smoke tests. Smoke tests verify the app is basically working after deployment. Examples. Get, actuator health, get, API version, post, API off, login, get, API orders, test. Smoke test flow. Deploy app, wait for readiness, run smoke tests, continue or rollback contract testing. Contract testing checks API compatibility between services. Useful for microservices. Consumer expects field, order ID. Provider accidentally removes order ID. Contract test fails before production. Tools. Pact, Spring Cloud Contract. Use contract tests for REST APIs, message contracts, event payloads, schema compatibility, pipeline observability. Monitor CI/CD itself. Build duration, test duration, failure rate, flaky test rate, deployment frequency, rollback frequency, lead time for changes, mean time to recovery, change failure rate. Useful metrics. How long does PR feedback take? Which tests are slow? Which stage fails most? How often do deployments roll back? CI/CD scalability best practices. Keep PR pipeline fast. Split slow and fast tests. Use dependency caching carefully. Build once, deploy many times. Tag images with commit SHA. Scan dependencies and images. Use quality gates. Automate smoke tests. Use Kubernetes readiness liveness probes. Use rolling updates by default. Use canary for risky changes. Use feature flags for gradual rollout. Use backward compatible database migrations. Keep rollback simple. Monitor after deployment. Upload build test artifacts. Avoid hard-coded secrets. Use reusable workflows. Parallelize independent jobs. Avoid rebuilding unaffected services. Common beginner mistakes. 1. Running everything on every PR. Bad. Every PR runs all E2E tests, all services, all load tests. Better. Fast PR checks, plus deeper release checks. 2. Rebuilding artifact for each environment. Bad. Build apps separately for dev, QA, staging, prod. Better. Build once, deploy same image everywhere. 3. Using latest tag only. Bad. Order service, latest. Better. Order service, commit SHA. Order service, v1.4.2. 4. No rollback plan. Bad. Deploy first, think later. Better. No rollback command before deployment. 5. No health probes. Without readiness, liveness probes, Kubernetes may send traffic too early or fail to recover stuck pods. 6. Hard coding secrets. Bad. DB password. My password. Better. Use Kubernetes secret or Cloud Secret Manager. 7. Ignoring database migration compatibility. App rollback can fail if database schema changed destructively. 8. No post-deployment monitoring. Pipeline success does not guarantee user success. Monitor production after release. Real-world example. Spring Boot order service pipeline. Architecture. GitHub repository. GitHub Actions. Maven build. Unit tests. Integration tests with test containers. Docker image build. Image scan. Push to GHCR. Deploy to Kubernetes. Smoke test. Prometheus, Grafana, monitoring. Spring Boot service. Order controller, order service, order repository, PostgreSQL, RabbitMQ, Redis. Pipeline stages. PR. Compile. Unit tests. Static analysis. Main. Full tests. Docker build. Image scan. Deploy dev. Release. Deploy staging. E2E tests. Manual approval. Production rolling update. Monitor GitHub Actions full example. Name Spring Boot CI/CD. On. Pull request. Push. Branches. Main. Env. Image. Name. ghcr.io/company/order service. Jobs. Test. Runs on Ubuntu latest. Steps. Uses. Actions/checkout at v4. Uses Actions setup Java at v4 with distribution Tamarin, Java version 21, cache Maven. Name. Run tests run. .mvnw. Clean verify. Docker needs test if github.ref equals refs heads main runs on Ubuntu latest. Permissions, contents, read, packages, write. Steps. Uses Actions checkout at v4. Uses Actions setup Java at v4 with distribution Tamarin, Java version 21, cache Maven. Name build jar. Run mavw clean package -d skip tests. Name. Login to GHCR. Run echo $secrets GitHub token. Docker login ghcr.io. $sign GitHub actor. Watch password stdin. Name. Build and push image. Docker build key. $image name $GitHub SHA daughter. Docker push $image name $GitHub SHA daughter. Kubernetes deploy step example. Deploy dev needs Docker. Steps. Uses Actions checkout at v4. Name. Configure kubeconfig run. mkdr-p/kube echo $secrets dev kubeconfig ec/kubeconfig. Name. Update image run. kubectl set image deployment order service. Order service equals ghcr.io company order service capital SHA dev. Wait for rollout run. kubectl rollout status deployment order service -ndev CI/CD scalability interview. Questions 1. What is CI/CD? CI/CD is an automated process for building, testing, packaging, and deploying software. 2. Why is CI/CD scalability important? Because as teams, services, and tests grow, pipelines must remain fast, reliable, and safe. 3. What does build once, deploy many times mean? It means creating one artifact or Docker image and promoting the same artifact across dev, QA, staging, and production. 4. Why avoid the latest Docker tag? Because it is hard to know exactly what version is deployed, and rollback becomes harder. 5. What is a rolling update? A rolling update gradually replaces old pods with new pods to reduce downtime. 6. What is blue-green deployment? Blue-green deployment uses two environments. One is live, and the new version is deployed to the other before switching traffic. 7. What is canary deployment? Canary deployment releases a new version to a small percentage of users first, then gradually increases traffic. 8. Why are readiness probes important? Readiness probes tell Kubernetes whether a pod is ready to receive traffic. 9. Why are liveness probes important? Liveness probes tell Kubernetes whether a pod is alive or should be restarted. 10. How do you make CI faster? Use caching, parallel jobs, test splitting, module-based builds, and avoid running unnecessary slow tests on every PR. 11. How do you handle database migrations safely? Use backward-compatible migrations, test in staging, avoid destructive changes first, and separate expand-contract steps. 12. What should be monitored after deployment? Monitor error rate, latency, CPU, memory, pod restarts, health checks, database errors, queue depth, and business metrics. 30-day learning plan, Week 1. CI/CD basics. Learn. CI/CD meaning. Maven and Gradle build. GitHub Actions basics. Unit tests. Build artifacts. Practice. Create CI pipeline for Spring Boot app. Week 2. Docker and registry. Learn. Key. Docker file. Docker image tags. Container registry. Buildpacks. Image scanning. Secrets handling. Practice. Build and push Spring Boot Docker image. Week 3. Kubernetes deployment. Learn. Deployment, service, config map, secret, readiness, liveness probes, rolling update, rollback. Practice. Deploy Spring Boot app to Kubernetes. Week 4. Production scalability. Learn where. Plus blue-green deployment, plus canary deployment, plus feature flags, plus database migrations, plus smoke tests, plus quality gates. Practice. Build production-ready CI/CD release pipeline. Final summary. CI/CD scalability with Spring Boot is essential for modern backend and cloud-native development. Important concepts include SACE, fast PR pipelines, automated builds, unit tests, integration tests, Docker images, container registry, Kubernetes deployment, readiness, liveness probes, rolling updates, blue-green deployment, canary deployment, feature flags, security scanning, database migration strategy, rollback planning, production monitoring. Backend developers already understand. Check. Java, Spring Boot, REST APIs, databases, testing, deployment. This makes CI/CD scalability easier to learn step by step. Key idea. Scalable CI/CD helps Spring Boot teams release faster, safer, and more reliably as applications, teams, and microservices grow.